Okay, so in this video we're just trying out some examples from the homework section for 5.3. So I'll pause for a moment and write one down. I guess I should have done that before I started. Okay, so let's integrate from 1 to 8, x to the minus 2/3 power dx. So first we have to find the antiderivative. And so the antiderivative in this case, let's see, minus 2/3 plus 1 would give me plus 1/3, and then this would be 1 over 1/3, right? Then we're going to evaluate from 1 to 8. So just to simplify that would be 3 times x to the 1/3 power, right? From 1 to 8. The 3 you can just bring out. And so that's the cube root of 8 minus the cube root of 1. The cube root of 8, do you remember that one? Or do you know that one? 2 times 2 times 2 is 8, so that's going to be 3 times 2 minus 1. I guess that's 3. Good. I'll pause and we'll write down the next one. Okay, so the next one, 0 to 4, the integral from 0 to 4, 4 minus t times the square root of t dt. So some of these we're going to have to do a little bit of algebra before we can find the antiderivative. And so for this one, we're going to want to multiply through by that t to the 1/2 power, right? So we'll just go ahead and write that as 4 minus t times t to the 1/2. So go ahead and multiply that through 4t to the 1/2 minus t to the 3/2. Good, and now we want to take the antiderivative of the integrand. So that would be, let's see, t to the 3/2 times 2/3 times 4, right? Minus t to the 5/2 2/5 from 0 to 4. It's probably good to go ahead and simplify that a little bit. Well, I guess that's not that much. 8/3. Let's go ahead and pull in the 4 then. That's 4 to the 3/2 minus 2/5 4 to the 5/2. And then minus, when you plug in 0, everything is going to be 0. Good, so this is the square root of 4 cubed, right? That's the square root of 4 cubed, which is 2 cubed, which is 8. So that's 16/3 minus the square root of 4, which is 2 to the 5th power. And 2 to the 5th is 32 times 2. Give us a 64 over 5. Okay, and then I suppose we could put this over a common fraction, or we could just maybe put this in our calculator. Well, that's okay. Oop, I see a boo-boo here. So this was, this first one was 8, or 2 cubed is 8, but 8 times 8 is not 16. Good. Okay, so that's 64. Good. So then, let's see. So we get 64 times 5, which is 320, minus 192, I guess, which is 64 times 3. And so that's going to give us 128 over 15, I believe. And okay, so that's enough for arithmetic. Okay, good. Let's try another one. Gosh, there's so many to choose from. Let me pause for a minute, see if anything looks good. Okay, so number 45 looked interesting. Here we have the integral from 0 to pi of f of x dx, where f of x is actually defined to be 2 different functions. Sine of x from 0 to pi over 2, cosine of x from pi over 2 to pi. Now just to see what that actually looks like, the sine of x going from 0 to pi over 2 would look something like that, right? Oops, sorry, that's cosine. Sine comes up and then stops at pi over 2. Of course, then it comes down, right? And then cosine does kind of the opposite, right? It starts up here, comes down, and then it comes down like that, right? Good. Okay, and so hopefully that's not too much information in there to get us going. So what would the integral, how would I set up this integral then? Notice that the function is not continuous, so we might have a problem, but actually we don't, because what we can do if we want to evaluate this is to go from 0 to pi over 2 with the sine of x, and then add in the integral from pi over 2 to pi of the cosine of x. And now on each of these individual pieces, right, our function is continuous. And so then we could go through and compute it. So the antiderivative of sine is minus the cosine from 0 to pi over 2. And what would that be? Minus cosine pi over 2 plus cosine of 0. And that's equal to 0 plus 1, which is 1. Good. And then so the area from here to here is 1. So actually, can you guess what the other one's going to be? That area is going to be minus 1, and then we're going to get 0, right? But let's just double check. Okay, so that's the sine is the antiderivative, so that's the sine of pi minus the sine of pi over 2. Okay, so what's the sine of pi? That's 0 minus sine of pi over 2 is 1. So we do get minus 1. And so then overall we have 1 minus 1 equals 0. Good. So geometrically, or graphically, you could have seen that as well. Good. So that was kind of a nice problem. Okay, let's try this one out. I'm going to modify number 61 a little bit. We'll say f of x is the curve, or the function they have there. T squared over t squared plus t plus 2 dt. And first, so our first question will be, where is f increasing? And so how are we going to figure out where f is increasing? Well, we can just take f prime of x, and that's the derivative of the integral, right? And so this is the fundamental theorem of calculus part 1, right, which says that that is equal to just your f of x, or sorry, we're using f of x in something else, but yeah, it's just the integrand with x stuck in. Good. Now, the denominator here does not factor. In fact, if you were to set this equal to 0, you would have complex solutions, right? And so, therefore, and the numerator, in addition, is always positive because it's x squared. So both numerator and denominator are always positive. So f prime is f is always decrease. F is always, let me see if I can spit this out, always increasing. Very good. Now, let's get to the heart of the matter here. Where is f concave up and concave down? Concave up, concave down. Yeah, now, if f prime of x is equal to x squared over x squared plus x plus 2, right, then what's f double prime of x? Yeah, we're going to need to use the quotient rule, right? And so derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom function squared. Good. And so let's see, go ahead and just multiply that through, I guess. 2x cubed plus 2x squared plus 4x minus 2x cubed plus x squared minus x squared. Good. Looks like the x cubed terms cancel. And we'll be left with 2x squared minus x squared is just x squared plus 4x divided by x squared plus x plus 2 squared. Good. Now, we've already determined that the denominator is always positive, right? And so squaring it's just going to make it more positive. And so we don't have to regard the denominator at all when we're just trying to figure out what the sign of the second derivative is. And so we just have x times x plus 4 on the top there. That's a parabola that opens up 0 and negative 4, I guess, huh? Is what it looks like. Good. So therefore, if x is less than negative 4 or greater than 0, concave up. If x is between minus 4 and 0, concave down. Very good. So those were some fun problems to work on. And that is... Oh, there's some more on the next page. Oh well. I guess I can't have all the fun. You'll have to have the fun for the next page. I'll see you later.